Okay, so let me share my screen. Can you see the software, the INTEGRANO data management tool software on the screen now?
Not yet.
Yes, sir. I see it.
Some yes and no. Can everybody see it now?
Yes, now we are seeing.
Yes. Okay, great. Okay, so when you open the INTEGRANO data management software, you are taken to this home page, and on this page you can see a variety of different links and pieces of information. So obviously this one here will take you to the INTEGRANO website, from which you can access the INTEGRANO private area. We've got an INTEGRANO glossary here, which is a living glossary, will be continually added to, and this contains all of the terms, acronyms, which are going to be heavily utilized within the INTEGRANO project. And then here we've got a user guide on how to use the data management platform, and that takes you to a web page hosted on the INTEGRANO website with videos on how to utilize the data management software. So there are already resources available and to help you in utilizing the software. At the top of the screen here, you can see the number of nanomaterials which have been inputted by partners into the software. So at the moment we have 18 different nanomaterials, and then we've got 7 life cycles created. Most of these are just test cases at the moment, which have been created during the last couple of weeks of testing of the software. There's 2 design cases, and obviously this is the number of partners within the INTEGRANO project. At the top you can edit your profile, so this is the profile of your organization. Here is a quick link to a design case study, which can also be accessed on the left-hand side via this drop-down tab. And then this top link here shows orders, and this is a very important part of the software. I'll just quickly click on it. And we'll talk about this a bit later, but this takes you directly to a page where you can see the orders which your organization has received if you are a provider of a nanomaterial or a nano-enabled product. And at the bottom, you can see orders which your organization has sent. So if you, for example, are a leader of a case study and you have created a life cycle, you will have requested or inputted a nanomaterial or a nano-enabled product into that life cycle, and as part of that you will have sent an order to the provider of that nanomaterial or nano-enabled product. So the list at the bottom of the screen shows you which orders you have sent and to which partners, but we'll talk about that a little bit later. Let's go back to the dashboard. So I think most of you will be familiar already with the software to a certain extent. Here we've got the nanomaterials portfolio. We've got the list of all of the nanomaterials within the INTEGRANO project listed on this page here. So you can see the acronym of the provider, text description of the nanomaterial, an acronym of the nanomaterial. Internal means that it will be internally produced by that provider. And then on the right-hand side is some notes which describe how that material has been synthesized. Now, if you want to input a new nanomaterial into this list, you can quite simply do so via these text boxes here. And this is really important to do for each new nanomaterial that you're going to be working on within the project, because each lifecycle stage which is created is unique to each nanomaterial. So if you are creating a series of, let's say, silver nanoparticles, but the synthesis of those nanoparticles is differing significantly, you need to create a new nanomaterial entry for each of those nanoparticles that are going to be synthesized by the different synthetic methods. And of course, you can update or delete the nanomaterial as you like from the entries that you have made. On the left-hand side, there's next the characterizations tab. And so these are all of the different characterizations that are able to be provided within the INTEGRANO consortium. So we've got the physical-chemical characterizations, functional and human toxicity, ecotox assessments, and emission exposure assessments. Excuse me a minute, I'll just let somebody into the meeting. Okay. So if we go to PChem to start off with, we've got on the screen listed all of the different PChem characterizations that have been indicated by partners as being important within the INTEGRANO project. This list can be added to if there are any characterization methods which are not already listed. So please let us know if any new characterization methods do need listing. Now, what we have been asking for partners to do over the last few weeks is for them to indicate whether their organization has a particular characterization technique, and if they do have it, to tick that as being available, and then entering information about that characterization technique, so the quantity of material required for analysis, we've got the measurement unit here, and the lead time for that analysis, so the time that it's taken between a partner requesting that analysis to the time when that analysis will be actually performed. And then we've got the test duration in hours, so how long the analysis will take to perform. If we scroll to the right of the screen, another couple of boxes to complete. So here, to indicate whether that characterization technique is destructive or whether the sample obviously can be recovered after it has been analyzed, and then the market cost of the analysis as well. So all of this information helps us to plan the characterization campaign within INTEGRANO. So that's a PChem and morphological, and most partners have indicated all of the characterization techniques that they can offer, but please do add to this list if you haven't already done so. Next, functional characterization. So this is a very similar format, and you can see all the different functional techniques that are available on this page. And then we have got human tox assessment. Again, same format. So our project have indicated we can cultivate skin cells and Almar blue tests here, just as an example. So I'll deselect those because obviously we can't provide them and we don't want to receive those requests during the project. But for each of those characterizations, if your organization can offer them, please do so. And so it's the same for ecotox and emission exposure assessment. Okay. Next, there is the modeling section. So this is for exposure modeling. So this is less complex. This is a simple tick box as to whether that is available or not within your organization. And then once you've selected, you should go to the red bar at the bottom and click on the save bar. And that's the same for all of the characterization methods as well in the previous drop-down list. So once you've added your entry, please make sure that entry is saved by clicking that red bar. So there's exposure and modeling, and also sustainability modeling. So we at Project Hub offer all the life cycle thinking methods, and so we've also selected these and saved them. And then in the software on the left hand side, next we've got the life cycle stages. So within INTEGRANO, we're looking at the synthesis, incorporation, use phase, and end of life phase of the nanomaterials and nano-enabled products. So if we click on the synthesis, so these are all of the methods which will be used within INTEGRANO to produce the nanomaterials. So if your organization can offer either any of these synthesis techniques, please indicate these. And this is essential for the construction of the life cycle cases, because when you enter a nanomaterial into the life cycle, you have to declare how that material is going to be synthesized. And so there needs to have been prior discussion with the material provider that they are able to do that. So that material provider needs to make sure they've selected the correct technique that they can offer. You obviously input all of the relevant information, such as the quantity that is able to be produced per batch, the availability, so the lead time until that synthesis starts to be performed, and then the synthesis duration in hours. So again, this helps with the planning of synthesis if a particular method was going to take a long time and there was going to be a queue, but I don't think that's actually the case in INTEGRANO. So the same for incorporation. All of the different incorporation methods which partners have so far indicated may be used within INTEGRANO, they are listed here. So again, if your organization will be performing these methods within the project, please input them on this page and then click Save Incorporation Portfolio at the bottom. And if there are any methods either in the synthesis or incorporation which have not yet been added, which need to be added to these lists, please let us know and we will make sure that they are included in there. Okay, so those are all of the elements of the drop-down list which you probably are already familiar with, and some of you will have looked at the life cycle part. Did somebody have a question? I heard anything.
Yes, so my question is related with the available amount per batch. I'm just remember right now, for example, our case and the bio case, because we are synthesize different materials and the available amount for each one could be different. How could we separate for each one?
So I guess we could either add multiple entries into the synthesis list based on the different type of equipment that you will be utilizing, or otherwise we can discuss what a sensible amount of batch would be. Please, somebody else? Fancy who's asking a question?
Sorry, Massimo, your microphone is muted.
Yeah, sorry. I wanted just to corroborate your answer, but please finalize your answer, Ben.
Yeah, I was just saying that obviously Centi are going to have different facilities which have different production capacities. So we could either include those in the list as separate entities, and then they can be added or removed as the project progresses, or we could maybe set the quantity at a minimum level, which can be provided by each of the batches, and potentially we can that can be exceeded on discussion with the partners. I don't know what you think, Massimo. Have you got anything you'd like to add to that?
Yeah, I mean, this is the way how to deal with this, because when you are providing information to the database about your facilities, you may have the same facility that has different using modes or mode of employment. So you can discriminate the mode of employments by differentiating the names of the facilities, like facility of silica nanoparticle synthesis 1, 2, 3, or 4, or maybe having a clear definition, self-explaining name that will allow you to select the proper operation mode of the same facility that you intend to use in the case study.
Yeah.
That could be the best.
Yeah, if we look at the list here, we can add a line of text underneath the headline method, as we saw in the incorporation. If I go to, so we can have a headline method, and then we can have a text description stating, the type of reactor that it is, and then obviously each reactor will have different batch quantities that are available. Does that sound workable, Lorena?
Okay, yeah, yes. Could be a nice idea to separate this.
Okay, and maybe then if you could provide us with a list of the different reactor types that would need to be added to that list, and we can get those added in, then you're able to fill in all of the information for each reactor type. That would be great.
Okay, thank you.
Thank you. Okay, so as mentioned, most of you are familiar with most of the elements on the drop-down list. Some of you may not yet have looked at how to create the individual life cycles or design cases within the software. So here we've got life cycle. We've got two options. We can create a new life cycle, or we can look at life cycles which have already been created. Let's quickly click on that. And so these are all the life cycles which have been created by Project Hub so far during the testing phase. So once we've created a life cycle, it will appear within this list. So I'll just go to life cycle here, new life cycle. And so a life cycle refers to the synthesis of a single nanomaterial or the production of a single nano-enabled product from a single nanomaterial. A life cycle doesn't cover an entire case study. It is specific to a specific material. So this is important to note, and you will see this as we go through. So what I want to do is just to create a fictional life cycle, just to show you exactly what needs to be done in order to provide sufficient detail around for this. So in terms of the life cycle, you can give it a name. So silver head test life cycle. Obviously, the date is set at today's date, and automatically the owner is set at Project Hub because I'm logged in with the Project Hub account. So normally the case study leader would create this life cycle, but it could be a material owner as well. Give a name for a contact for that particular life cycle, and then there starts to be some descriptive text boxes. So this is where we start to add information about the life cycle. And this is all to provide information for somebody else who is not familiar with that life cycle to understand what it's all about. Because remember, in Integrano, we have to produce data which is fair data, which can also be utilized during and after the life of the project. And so we need to make sure that all the data is collected right from the outset so that people can understand the context in which data was collected, in the context in which nanomaterials were synthesized. So assumptions are hypotheses. So for silver nanoparticles coated with HEP, we can say maybe, for example, the degree of surface functionalization is related to the level of antibacterial activity, for example. I'm not an expert in silver nanoparticles, but sounds a plausible assumption or hypothesis. And then there's a cutoff here. So, this can be where you say you're going to neglect any results in a region of uncertainty for measurement, or, for example, neglect results where surface capping is less than 30% due to agglomeration. You can maybe cite a literature paper. So this can be something that you know from previous work or from literature, where you know that there is a cutoff. I think there was a question.
Yes, this is also a remark relating to the cutoffs, because depending on the context you are applying this term, this concept, it takes a different meaning. So, for instance, for the LCA and LCC, cutoff means all the contributors to the impacts which are below, say, 3% of the total impact. So these will be specified, for instance, in the LCA analysis and LCC. Or if you are not considering by measurements some quantities that are below some threshold, you can specify. So this is more quantitative description of the cutoffs. This is normally included in the goal and scope of each study. And since we are somehow referring to the ISO standards for LC and LCC, we are keeping this as a relevant point, because it will also provide the level of results, data quality, in representativeness, what we are analyzing. So it's very important to pop in some relevant information here. Thank you.
Thank you, Massimo. So was there another question? No? Okay. So next, you select the partners which are involved in this particular life cycle stage, and so who is involved in the synthesis of these nanoparticles. So we can just select some partners here. We are aware that this list needs to be updated because there is a bit of repetition for the CNR institutes, so that is in progress, so we know about that issue. So select the partners involved, and then here we can select which phase of the life cycle we're looking at. So we can have the experimental, synthesis, incorporation, use phase, or end of life. You can see you can only select one of these at once. So we'll go with experimental synthesis. And now we have to select the nanomaterial which we are focusing on within this particular life cycle phase. So this is why it's really important that the nanomaterial is entered into the nanomaterials portfolio, because this then results in it being available for selection within this list. And you can click on the blue bar and it will give a description of the nanomaterial, who the owner is, any notes about that particular material. So if there are multiple silver nanoparticles in the list, you can see what the difference is between them by clicking on the blue bar. So we'll go with silver nanoparticles coded by HEC, and so you just click and drag it to select that nanomaterial. And you can only select one nanomaterial at a time because each of these life cycle stages is unique to a specific single nanomaterial. Okay. So again, more descriptive text boxes, so scope. So why are you performing this life cycle? What are the applications? Give some good descriptive content about that. And then the system, so that should be well described. So if it's just a synthesis, it could just be the reactor in which the synthesis is being performed. But all the KPIs should be included in the system described. That's really important. So make sure you give some good description of the system here. System boundaries. I don't know if Massimo wants to add any content here, being the life cycle expert, but I mean this is life cycle thinking considerations. So synthesis would normally be in the laboratory, for example, but please, Massimo, if you want to add any.
Yes, I mean, now for this case, it's quite clear what is the boundary of the analysis. I mean, it's a synthesis process itself. So physical boundaries are the boundaries of the laboratory premises in which the reactor or the synthesis unit is installed. We have to specify that we are considering, say, from cradle to gate. So for the delivery of the nanomaterials, which will be sent to some other partner. If we are, for instance, considering the use phase, which is a little bit more tricky than incorporation and synthesis, we have to specify what are the condition of use and the environment where these are used. Just a moment, please. Yeah. So this has to be specified in terms of description. It's a narrative, but it's really important in order to identify the context. It's also in this the stakeholders will emerge as relevant actors in the system. So if you are, for instance, considering incorporation, then the stakeholders, the people that are involved in this activity are the operators. The working exposure will be somehow addressed in this case, and so on and so forth. So the boundary of the system should be specified. If any transport or any sending of material from A to B is implied, or if you are considering the suppliers of reagents, for instance, or not, if you consider a gate-to-gate, so you consider all the materials available at your entry gates, say, for free in terms of avoiding transport and production and other upstream burdens. So this has to be specified quite clearly, because this defines the system boundary. So the functional unit intended will be based also on the definitions. Thank you.
Thank you, Massimo. Next, a functional unit needs to be specified. So in terms of silver nanoparticles, this could be the amount of nanomaterial complying with a given level of antibacterial activity. And there's a time horizon implied within this, because the antibacterial activity is normally measured as a function of time, and that's specified in the assay. So we have a time horizon included within this assessment. Okay, so moving on, we've got the goal. So the goal is to synthesize antibacterial nanoparticles, and then we can state what the objectives of the life cycle are. So this could be to go beyond the state of the art, for example, achieving equal functionality at reduced cost. So we've got an objective of the life cycle stage here to synthesize nanoparticles with a given level of antibacterial activity, but that to reduce cost relative to the current state of the art. And then in terms of criteria, so it's a life cycle focused on substitution or innovation, for example, to achieve objectives. So that can be stated in the criteria box there. So here you can provide in strategy a text description of the strategy that you will use to achieve the objectives, and you can either state whether this is a new design or whether it is a redesign. So you're able to input those criteria. Please, there's a question.
Yes, thank you, Ben. Very clear. I wanted to make a comment on this, also addressing our experience with Anna. So by filling in all this information, we will already contextualize the case study according to the GRC framework. So all the questions that we were asked for the stakeholder workshops, etc., are already answered. It's very important to somehow characterize and contextualize the case study according to strategies, goal and scope, etc. In order to have all this information declared, because this is to be compliant with the GRC framework. That's it. Thank you.
Thank you, Massimo. Okay, so getting on to who is actually going to perform the synthesis of this nanomaterial. So you can see here listed all the different methods which are available in the life cycle stages drop-down menu. So this is again important, why all of the relevant synthesis techniques have been added in beforehand in order to allow the full range of synthesis methods to be available in this box here. So you can click on each method and you can see which partners within INTEGRANO offer that particular synthesis technique. So sol-gel, solid chemical, solution combustion synthesis, etc., etc. And I think now most partners have added the techniques that they will offer. And so for the silver nanoparticles, we'll go with sol-gel synthesis offered by CNR ISMC. I think in the consortium, there may be a couple of nanoparticles which are bought in from outside, and so you can click on external if that was to be the case. So just remember that option there is available as well. So we've selected the partner who will perform the synthesis, and that partner is the one which the material order will go to which we will show you in a few minutes. So it's important that this is selected correctly within the design of this life cycle. So now we get down to inputting the key performance indicators and the key decision factors for this particular life cycle. And so you can see there's a range of different KPIs that can be added in. We've got safety, environmental, there are the cost and social KPIs, and also functional KPIs. There are the physical chemical features as well. So these are essentially the characterization methods that you will utilize on the materials being produced. The physical chemical features may also be a KPI, depending on, for example, if nanoparticle size is a key performance indicator, and these can be added in this box here. And in this box here, this is where we add the key decision factors. So let's go back up to the top. So to add a KPI, you just simply click on the red box, and you appears safety KPI 1. If you want to add more than one safety KPI, all you need to do is click twice, or click a second time on that KPI. So you can see now we've got KPI 1, and below that we have KPI 2, into which you can input all of the details. So I'll just remove these. So we will add a functional KPI for this silver HEC nanomaterial. So we need to give the name of the KPI. So we can say antibacterial activity, quantity definition. So mean inhibitory concentration. So it's the lowest quantity of substance associated with 50% effect. So define what the KPI is actually assessing. In terms of units of measurement, so we'll go with micrograms per milliliter. And then the ranges, so these are the ranges defined by instruments, so the detection limit of the instruments being utilized to assess the KPI, and also by any minimum or maximum values within the design of the experiments matrix. So for this, we could put, for example, 0.1 micrograms per milliliter, all the way up to 10 micrograms per milliliter, just as an example. The method of measurements of essentially who's going to perform the assessment of this KPI. And so we've got antimicrobial, antibacterial. Here in this list, you can see there's a range of other different functional characterizations as well. So we will click on that. And you can see here we've got a section of different partners who can offer this functional characterization. So we'll go with bar ilan, and then you can confirm at the bottom. Like that. So you can see there that the method has been inputted and the provider. And then you can give the instrument, which has been utilized to measure the KPI. And so Synergy plate reader, which is an appropriate piece of equipment for that. You can give the make and model of the plate reader. Now here is quite important because the KPI is normally maximized by default. Here, for antibacterial activity, it could be that the lower the antibacterial activity, the better. And so we can click that if that is appropriate. And we can consider results below or above thresholds as well. So we can state those thresholds in these text boxes as well. Okay, and so once all the information has been filled in, that is that KPI added to that life cycle. Next, we can add PCFs, for example. So all of the nanomaterials being synthesized within INTEGRANO will have physical chemical features associated with them. So, for example, size, the quantity definition. So this is the intensity weighted mean hydrodynamic size. Unit of measurement, so give the unit of nanometers, and then the ranges. And so looked at between 1 and 100 nanometers for these nanomaterials, for example. Again, the method of measurement, so how will this size KPI be assessed? So we can give the technique, so dynamic light scattering, and then we can choose a partner within the INTEGRANO consortium. And so we'll go with CNR ISSMC, but in reality, you will have had discussions with that partner beforehand to check that they will be able to run this, just to make sure that things are available. So click on confirm, and that is all entered in there. We can give again the instrument, so we can go zeta size, now Z. Here in this case, minimize or maximize, it doesn't really make a difference. We're just assessing the nanomaterial size, so we'll leave that blank. And then we're looking for a nanomaterial below 100 nanometers, for example, so we can add that in there. And that is that KPI added. So you can add as many KPIs or PCFs as you want, just keep clicking the red box for add new PCF. Then we can add a new KDF. Go down the screen. So it's a silver HEC nanomaterial, so we can add a KDF, which is the ratio of silver to HEC. Measurement unit, well, it doesn't have any units, it's a ratio, so we can look between the ranges of 0.2 and 1. And if that variable is continuous, you can select the box there. So that's that KDF now added. You can add a new KDF if you want, or you can delete one. And then once everything is selected and filled in, you can click on save at the bottom to save at lifecycle stage. I think there was a question, please.
Yes, just a remark related to the PCF, the physical chemical features. Can you hear me?
Yes, yes.
Oh, okay, and of course, the case study for the multi-optimization will be based on the KPIs, maximization or minimization. Sometimes we don't know what we should address as a target for the PCF. So we will learn also by doing the case study experiments. So this will, just to inform you that this will not affect at any level the optimization or the multi-optimization in order to get more sustainable, more efficient and lower environmental impact solutions. But we can, if we already know, select and flag these desired maximization or minimization of the PCF. The PCFs may be also used in the synthesis phase, for instance, or incorporation phase as KPIs. Indeed, you see PChem KPI 1 and 2 and 3, etc., because they could be also targeted characteristics of our nanomaterials if we are applying the grouping PM, for instance, or the read across, because we know we want to reach some size of nano powders or nanomaterials for any reason. So it's twofold. The first is not affecting the general case study, but if you're using PCF as a target, say functionality or KPI in your synthesis, then it can play a role as long as you flag the maximization or minimization of these physical-chemical quantities. Thank you.
Thank you, Massimo. Okay, so we click on lifecycle, save lifecycle stage, and you get a message to say that it has been saved. So click on OK. And then if we go to design case study stage, it will bring up a list of all of the lifecycle stages that have been created by Project Hub, and you can see here we've got silver HEC test lifecycle, and on the right-hand side are a series of options. So here is an option to modify the lifecycle case. So we are working on enabling that. It isn't activated yet. The reason being is because if you look at the button on the right-hand side, we are able to send the nanomaterial order So the silver heck, we're able to order that from CNR. The problem is if we start to modify the life cycle after the order has been sent, that could impact significantly on the material that we're asking for. So we're just trying to implement this really carefully so that only elements within the life cycle stage which can be safely modified after an order has been sent and can be accessed. So that will be available soon, but for the moment, it's not yet, the feature is not yet available. So if we click on nanomaterial order, you can see we can request a quantity of silver heck. So let's say 100 grams, and give the units there. So we've got, so asking for 100 grams of silver heck from the provider that we selected within the life cycle that we have just created. We can add any notes and accompany the order, and then we can click on send order, and that order will be sent to CNR ISSMC, and they will receive that order when they log into the software by clicking on the orders page. If you go to the orders button at the top there, they will receive that order in the list at the top. This list is for project hubs orders which we have received. So CNR will receive the silver heck order in their corresponding list. We go down to orders sent at the bottom. So these are the orders which project hub have sent. You can see here we've sent it to SSMC, and you can see that sent status there. It looks like there's a slight bug in the software lex. It says external instead of ISSMC, so that will be rectified. Please, there's a question.
I've seen that Ilaria informed that the order was received, so
Okay.
virtually, I think.
That's great. Yeah. Sorry, I can't see who's writing because I'm looking at the software. So thanks for that. But yeah,
that's right, Ilaria. So I've seen this message in the chat.
Yeah, sorry, I was looking at the software. So if it's problem, I close it. I was just curious to see.
An order, right?
Yeah, in real time.
In real time, right? Thank you.
That's good. Well, that's an unexpected validation that the software is functioning as it should do. So that's great. Okay, so when a partner receives an order, they will get that order at the top of the screen on the orders page, and it will be highlighted as order which has been received. So this is just a fake order that Project Hub have received for cellulose acetate nanofibers. Obviously, we don't provide cellulose acetate nanofibers, but once you receive your order, you can click that button which says start production, and that will date and timestamp receipt of your order there. You can write a note to the person who has, or to the organization which has ordered the cellulose acetate if you want. If you want to give an estimated lead time or any bottlenecks or anything like that, then just simply click start order, and that will switch to processing. So you can see that order at the top switch to processing. Once your organization has completed the synthesis of production of whatever has been ordered, you can click on the green icon again and click on end order, and the status changes to elaborated. And now once you are on the elaborated stage, that means the material actually exists, and so you can create a label for that material. You can see in red to the right hand side is highlighted technical data sheet, but we cannot access that yet because we have to first generate a label. So this blocking of progression is deliberate so that each material which is produced within INTEGRANO is given an appropriate label from the outset, so there can be no confusion between similar samples. And this helps with the traceability of the materials. So to create the label, just click on that icon there, and this pop-up appears with instructions on how to compile the label. And this is the same as the presentation which I circulated around yesterday. And so you can give the material any modification, for example, the form of the material, and then a batch number. And then once you've added that in, you can give the label and click on Save Label, and that label will be produced, ready and available for you to use. So here is one which has already been labeled. So if we click on that, you can see that the label appears, and then you can save and print that. And so this will physically go, well, it will send the label to a printer to be printed, so you can stick it onto the container into which you are going to store or transport the material. Once you've produced the label, you are able to access the technical data sheet. So if we click on that, you can see here a series of text input boxes which ask for a description of the nanomaterial or nano-enabled product. And this is based on the template which is provided to us by Anna and Ilaria. So that can be filled in, and once you've done that, you can click on Save Changes, and that will be the technical data sheet which will accompany the material, which will accompany the material throughout its route within the INTEGRANO project. It will be available, a copy of that sheet will be available online, but it can also be printed out and physically sent with the material to the recipient. Okay. Once the technical data sheet has been completed, you're able to create a barcode. This is another item which we are still working on implementing, but this will be also available very soon. And then you can click on that box there, and that you can set up the delivery of the material with the partner who are going to be receiving it. So it's a very powerful and hopefully intuitive system that is enabling two-way communication between the organization ordering the material and the organization providing the material. But it also provides a way of ensuring that the material is entirely traceable throughout its synthesis and transport within the INTEGRANO project. Okay. Does anybody else have any questions about the orders page? Or am I okay to switch back to looking at developing the design case?
Benjamin, just a question. So the available materials to be ordered will appear just to the partners that is involved during the creation of the life cycle stage, right?
Yes, so only the partner who is selected as the material producer will see the order that has been placed, and that will be available on their version of the software when they log in with their username and password. Yeah, the fact that the order has been placed will not be available, at least at the moment, to any of the other partners involved in that case study. It's only something that can be seen between the organization sending the order and the organization receiving the order.
Okay, thank you.
Did that answer the question? Yeah, okay. Okay, so we've looked at creating a new life cycle and also the created life cycles. So now we can move on to the design case. So again, design cases which have been produced are listed here. But what we want to do is we want to essentially link different life cycle stages together for a particular material to produce an overall design case. And so it's easy enough to do. So we give the design case a name. Let's just call this one Silver Heck Cotton, for example. But the date, the partner owner, my naming, the scope of the design case. So give some information outlining the scope of what they're trying to achieve. And then you can see listed all of the available life cycles here, and you can click on the blue box and it gives you a little bit of information about each of the life cycles which are available. And on the right-hand side, you can see the owner, and you can utilize a design case, which we'll see in a minute. And you can also open up the technical data sheet for the material that is within that particular life cycle stage. So before you select one of these life cycles for incorporation within a final design case, you can see exactly what the material is present within the life cycle. So we want to link, for example, a synthesis and an incorporation step together within a case study. So there are a set of rules which dictate how we should do this, and it's pretty intuitive. Obviously, synthesis has to come before incorporation, which has to come before use phase, which has to come before end of life. We can obviously miss out a couple of intermediate steps, so synthesis and then end of life could be looked at within a particular design case. Well, this is just to point out the obvious, not to put the incorporation step before, for example, the synthesis step, because in reality, it doesn't work like that. So to select one of the life cycles, we just simply click on that chain icon, and at the bottom of the screen, that synthesis life cycle has appeared there. And then we can choose an incorporation life cycle, which will be independently created for this particular design case. This doesn't make any sense, this example, really, because it's cellulose acetate nanofibers and then the incorporation of Egyptian blue following the synthesis. But obviously, a bespoke incorporation phase or life cycle would be created for that. And then once you've got the two together, or 3 or 4 different life cycles together that you wish, you just click on Save Design Case, and the new design case has been saved. So that's really all of the, for the moment, in terms of what the software is able to do. That's a demonstration of how to create the life cycle cases and incorporate them within a design case study. Further implementations of the software will enable the entry of data which is collected into the software. But for the moment, we are in a position where for each of the case studies, the material owners and the case study owners should be able to start to utilize the software to build their case studies, the individual elements within their case studies, to generate these final design cases. And obviously, we've got this ordering system now, which is extremely powerful, and which will allow a good degree of tracking within the INTEGRANO consortium. And for the materials which have already been synthesized and sent to partners, we still need you to input all of the data into the software. But obviously, for the orders section, you can just go through the stages and produce the labels and the technical data sheets based on the data which has already been collected. And this is important because the creation of the lifecycle stages and the input of the KPIs and the KDFs creates database tables which underpin this software. And so this provides a slot essentially where the data will be inputted in the future for each of these design cases. So please, for the case studies for which work has already been progressed, please make sure that you create life cycle stages and design cases for these. Okay, so minimize the software, open the floor if anybody has any questions or queries.
So just to be sure, the life cycles should be created by the nanomaterials owners?
Not necessarily. Not necessarily. It can be created by a case study owner. You know, because we've got the ordering system in place, which allows the ordering of one partner. So it could be an internal order. You know, the material owner could be creating the lifecycle state and sending the order to themselves. That's perfectly fine as well. If the case study owner wants to take charge of this, that's fine. There's no right or wrong way of doing it. And I guess the person overseeing the case study may be the best person, but that should be something that is discussed within each case study itself.
Okay. Okay.
Okay. Does anybody else have any further questions? Okay, that's good. Well, thank you very much for attending. As always, we are here and available if you've got any questions. I'm sure people will have questions. If you see any bugs in the software, because we're just coming out of this implementation phase, but we received only a few emails of feedback. So if anybody has any issues or anything like that, of course, please let us know, and we will rectify them as soon as we possibly can. I hope you enjoy using the software. I mean, it's certainly really innovative and powerful with respect to what has been attempted in earlier European projects. And so for us as well, it's a very exciting time to be able to implement this and to see how it helps the INTEGRANO project in terms of material tracking and data tracking and ensuring that fair data is produced throughout the project. Okay, then. Massimo, did you want to say anything, or is it all okay from your side?
Yeah, I'm jumping right now on a call with the European Commission, so I think everything was clear. I just please ask you use it, because it was a huge effort beyond the OA of the project, but we are already stepping a step forward in order to organize data, and we'll move to the project officer, all scientists in the project. Data collection in harmonized way can be possible, and we can extract very useful information for science, technology, sustainability, and safe solutions to be promoted in the project. Thank you all.
Thank you, Massimo. And just finally, I will make the recording of this presentation available on the INTEGRANO private area, and it will have English subtitles in case you struggle to follow my Northern English accent. Okay, so thank you very much. Have a nice rest of the week, and we will speak to you soon and see you all at the ADM in January.
Okay. Thank you. Bye-bye.
Thank
you. Bye.
Thank you. Bye.
Bye.
Thank you. Bye. Bye.
Bye. Bye. Bye.
Bye.